Okay, we're solving exercises from the planning workshop, and we were dealing with a linear inequality. We already found the table of values for step 1, and then with that table of values we did a graph in the step 2 of the linear inequality. Then we found the intercepts, like in which places the graph crosses with the x-axis and with the y-axis. And now we're going to work with the other steps, which are basically the domain, the range, the type of graph that we have, and the growth intervals. Okay, so domain and range. For domain and range, we need to check the drawing, and you can see that domain means verifying where's the drawing from left to right. And you can see that because there's a line in here, like this thing is starting from the left and is moving toward positive infinity, so it's from left to right, so the domain will be R. And the range, because the drawing is also going from the bottom, to up to the top, that means that the range is also going to be R. That's usually what happens with linear inequalities. The domain and the range are R and R. Okay, unless you have a vertical line or a horizontal line, it might be different. But if the line is a diagonal line, then it's always going to be R and R for both of them. Then the type of graph that we have in here, we know that thing was a linear inequality from the beginning. So it's a linear inequality because of the type of drawing and also because of the symbol greater than. But it's not the only thing we need to put. Okay, something important about linear inequalities is that we need to understand that those things are not functions. So it is important to specify that. Let's say it's not a function. Okay, so that thing is not a function, and inside parentheses I explain what it is. It's a linear inequality. If it were a linear function, quadratic function, absolute value function, then you just put which type of function it is. In this case, it's not a function, it's a linear inequality. And the growth intervals, they kind of like, that's kind of like the reason why you put it's not a function, because by explaining that, you can justify that in the step 6, you're going to put that it's not applicable. Because growth intervals only exist in functions. They don't exist in relations that are not functions, like linear inequalities. There is no meaning on growth intervals. Okay, because growth intervals, what they do is that, okay, I'm going to put not applicable, and I can explain that it's not a function. Okay. Okay, so it's not applicable because the graph is not a function. Okay, now why is it not applicable? Well, if you see a drawing like this one, there is no way to say that it's going up or that it's going down or something like that. Like, it makes no sense, because if everything is colored, there is no up, down, or whatever. You have everything colored. Okay, like the meaning of increasing means that you have a drawing that is going up. Decreasing means that you have a drawing that is going down. Constant means that you have a drawing that is horizontal. But when you have a drawing that is inside the area that you're drawing, you don't have a line that's either going up or down or horizontal, but instead you have everything colored. There's no way to say that thing is going up, down. It makes no sense. Everything is colored. So that's the reason why this thing is not applicable. So those will be the last steps of this exercise of linear inequalities.